I have done hundreds of code review and I keep seeing the same cookies security mistakes over and over again. Developer either don't understand how cookies works or they misconfigure them in a way and which leaves your application open for attack. So in this video, we are going to talk a lot about cookies integrations, how you can secure the cookies, how to implement secure cookies in NestJS, real attack scenarios if you're not configuring cookies correctly. So this cookies knowledge that separates junior developer with the senior developer. So what are cookies? Let's start from the absolute basic, very basic. What are cookies? Cookies are nothing but a small part of information that server sends to the browser and browser store them and automatically send back with each and every request to the same domain. Why do we need cookies? Remember logged in user across different HTTP requests because HTTP is stateless. Once I send the request, receive the response. Server doesn't know anything about me. It doesn't track the previous request. So to help server identify my user identity again in the next request, I need to send cookies, tokens, session ID and all these things, right? Shopping cart, keep cart items when you are navigating between different pages. Reference like remember language, theme, settings. For all sort of things, remembering session, settings, user settings, we can use cookies. Now how cookies works? User logs in to the server. Server sends these cookies. Server will do a set cookies, some method, which will send cookies to the browser. Browser will store it, and in every subsequent request, browser will automatically send those cookies back to the same domain, right? Cookies sent automatically. You don't need to do anything. No JavaScript needed here. It's a browser thing because the cookies has been received for a particular domain. Now all the other requests which we are making will forward the same set of cookies. This is important aspect, how we set the cookies header, because server is sending the cookies to the browser. And what are the parameters of the cookies? Name, key value pair, session, session ID, token. Domain means what is your API domain using which you are sending the cookies, right? Path, expire, maximum age of the cookies. HTTP only, so that when the cookies has been sent to the client, JavaScript cannot access those cookies. Secure, exchange of these cookies happens only on HTTPS. SameSite means it is strict. You can exchange this cookie only for this particular domain. Strict, lax or none. So these are the 5 parameters which decides everything about cookies. HTTP only. Cookies cannot be accessed by JavaScript. Protected against XSS attack stealing your session. Secure. Cookies are sent over HTTPS connections only. Prevent man-in-middle attack if you are using without HTTPS. SameSite. Cookies not sent with the cross-site request. Strong CSRF protection. That means those cookies can exchange on the same domain. SameSite lax. Cookies sent with the top-level navigation. Good balance of security and usability. This is like lax means if you are using subdomain, then those can be used. SameSite none. Cookies sent with all requests required for cross-site but needed a secure flag. So these are 3 parameters: SameSite, strict, none and lax. There is not much big difference between strict, none and lax. Strict means cookies not sent with the cross-site request. Strongest CSRF protection, right? Cookies cannot be sent if the cross-site requests are being sent. That means your client and server are on different domain, and if you try to send the cookies to that API, that is not possible, right? SameSite lax means if you are even using the root level domain, in that case, the cookies will be sent. So how we can prevent the attacks? When you are using HTTP only, malicious JavaScript code cannot access the cookies sent by the server to the browser, right? So here XSS cannot steal HTTP only cookies because with the JavaScript code you cannot access them. And here, if there is an evil website and which is trying to steal the cookies, if you are using the SameSite strict, cookies not sent from other domain. CSRF is blocking. Your cookies are only for your domain. So your server is sending only for your domain. If somebody is trying to, evil website is trying to hit your APIs and try to extract the cookies from the API response, that is not possible, right? Because these cookies sent from the server are not sent cross-site, only for the origin which is authorized. So to explain a CSRF attack, I will explain you something like this. Let's say you logged into your bank website. You get the cookies, session HTTP only. Now browser store the cookies because your session exists. Now user visits another website, attacker website, which is stealing the cookies. User clicks onto the link on the email and which lands him to the attacker website. Now they have this hidden form somewhere. So what it is doing is action dot transfer, or it can be something which is private to the API, and it is trying to steal your cookies and send it back, because here you are going to send a form and the cookies of your bank website which you already have on the browser is we are trying to send. Browser send the bank cookies with malicious request because you didn't set the same site protection in the cookies. So browser automatically attaches the session cookies to the cross-site post request. This form is not on your bank website. This is hidden form on the evil website or any evilmonster.com, right? This is the hidden form, but as you don't have a same site protection, these cookies will be attached and sent to your private API, which can be accessed through the cookies. And if they are able to access the cookies, that means the task is done for the attacker. This is what I was trying to explain. So to explain it visually, user logs in, visits the evil.com, there is a hidden form, post transfer, cookies will be attached. If you don't have a same site, your bank will consider, okay, this is a legit request, let's allow it. Without same site, cookies is sent, cross-site request, server accepted, and bank attacker succeeded. But when we are saying same site strict, browser blocks the cookies on the cross-site request. No session request directly rejected. That means evil.com cannot use a hidden form to send the cookies to the bank API. We will come to the code. What code is nothing different here. We are writing a simple login. If your credentials are valid, we can attach the cookies something like this. HTTP true, secure true, same site strict, maximum is 1 day, path is this. So these cookies will be attached in the response, will send to the browser will keep sending it. Now reading the cookies, now all the request will be start sending the cookies in the some header. So we can actually just read the cookies from the cookies, or like here request.cookies auth token, because I set the cookies as a auth token in the response. Now in the other API request, you will be sending the same cookies and I will get it and I will validate, verify the token, extract the user session, and all those things will happen. So this is like a cookies guard. I will allow you to access my private APIs if you are sending the auth token cookies and that cookies is valid. I validate the token and then only I will allow. Okay. You can actually, I don't care if you want to send the JWT token in the cookies. The exchange is happening automatically. You don't need to send this token in the authorization barrier header. No, right? Because browser, it's a cookies. Browser will send it automatically in every next request. If you are sending a token, then you can just send it in the response.json. Then it will become a token based authentication. There you need to set it in the headers from the client while sending the request to the server. So this is divided into two sections. Okay, this is all about cookies and understanding the security of the cookies. Another is thing we are going to talk about NestJS with the cookie based authentication end to end with the type ORM, Redis and all.